So lesson number 5 takes what we learned in lesson 3 and 4 with the normal distribution curve and puts it into problem-solving contexts that we can then use to actually solve examples or real-life situations where the normal distribution curve becomes important. So a light bulb manufacturer produces 35,000 light bulbs. From the past data, so the samples that they have tested, light bulbs are normally distributed. They have a mean of 900 hours and a standard deviation of 50 hours. So question A says predict the number of light bulbs or the percentage of light bulbs that will last between 825 and 875 hours. So 900 hours is right here. And I want from 875 to 825. So this is the area that I want. And I can use my z-score table to find out that area. But in order to use the z-score table, I have to convert these particular values, the 875 and the 825, to z-scores. So if I do 825, the z-score for 825 is x, which is 825, minus the average, which was 900, divided by the standard deviation. If I do that, for an answer, I get negative 1.5. So what I want you to do is I want you to calculate what the z-score for 875 is. So this one would be 875 minus 900 divided by 50. And what did you get, Lane?
Negative 0.5.
So now when I look on my z-score table, what is the area to the left of a z-score of negative 1.5? So that's where you grab your table. And I would be looking at negative 1.50. And to the left, I get 0.0668. So that was my z-score of 1.5. What is the z-score for negative 0.5?
0.3085.
So this 0.3085, that's the area from this point to the left, and the 0.0068 is from this point to the left. So the area in between, how would I find out the area I have shaded in blue? What would I do with these two areas? Would I add them?
Minus 875's z-score from 825.
I would subtract these two areas. So I would subtract the area, the 0.3085, because that's everything to the left, and this is everything to the left, and I'd be left with this part in between. Does that make sense?
I'll second the motion.
And what do I get when I subtract those two areas?
.2417.
Okay. What is that as a percentage?
24.17.
Good. So I could predict that about 24% of the light bulbs will last between 825 and 875 hours. So of the 35,000 light bulbs, how many light bulbs would that be? Well, this would be 24.17% of the 35,000. So in order to multiply by a percent, what do I need to do with it? What'd you get, Dylan?
Well, I don't think I did it right. I just went 35,000 divided by 24. What was that?
Would I divide or would I multiply?
I'm thinking that she just you would definitely multiply.
Okay, but what would I do? Would I multiply by 24.17 or would I change that percentage to something else?
Wouldn't it be 0.24?
Yes. So 0.2417 times the 35,000.
You get like 8,459.
Okay, so would that be 459 or 460?
460.
So just about 8,500 light bulbs would last between 825 and 875 hours. Okay, if I look at Part C says determine the probability that a light bulb selected at random will last less than 920 hours. What is in the middle? 900. So then 920 would be to the right of that. And I want the probability that it will last less than 920 hours. So how do I figure that out? What do I need to find out?
I'm thinking Z-score.
You're thinking Z-score, so what is the Z-score for 920? Figure that out for me. So if I calculate the Z-score, 920 minus 900 divided by 50, I get 0.4. Now what do I do with that Z-score?
Would you minus it from the other Z-score?
Do I need to subtract it from the, what other Z-score do I have?
If you found the Z-score for the 900,
From the 900 or the 920? So if I look on my Z-score table for 0.4, what is that going to give me?
0.6554.
0.6554?
Yep.
What does that represent?
area,
100.
920 to 900.
Not 920 to 900, to the left of 920. So it's everything from 920 to the left indefinitely. Is that what I need? So there's my probability. The probability that the light bulb will last less than 929 or 920 hours would be 0.6554. If I changed it to a percentage, it would be 65.54%. But this would be my probability. Okay, so look at class example number 2. A certain strain of the flu is determined to have a mean of 12 days and a standard deviation of 3 days. If we suppose that the data is normally distributed and you caught this strain of the flu, what is the probability that the flu is going to last more than 17 days? So what is in the center of my Z-score table?
12.
So where would 17 be?
Just to the right.
Okay, and at 3 days, I'd be at 15, 18. So I'm almost 2 standard deviations away. Okay, am I shading the area to the left or to the right of 17?
The right.
To the right. So what am I going to need to find out first?
Left side.
Before I find out the left side, though. In order to look on that chart, what do I need to know? The Z-score. So I need to convert this to a Z-score. So convert 17 to an appropriate Z-score, please. I can go 2 decimal places, right? 1 point. So this would be 1.67. So if I want to find the area
Can I go use the washroom, please?
that is greater than,
0.95.
so I need this part that's greater than 1.67. How would I find that out? So what happens when I look up 1.67? What do I get?
0.95.
So 0.9525?
Yep.
And what does that represent?
Your whole area to your left.
So it's from this point to the left. So how do I find out the stuff to the right?
Take it away from 100%.
From 100%, which as a decimal, 100% would be 1. And what is 1 minus 0.9525?
0.0475.
So to the nearest hundredth, what would that number be?
5.
Or about a 5% chance that the flu is going to last more than 17 days. Between 13 and 15 days. So where would I find 13?
Just right in front of them.
And then 15 would be a little bit further. And I want the shaded area in between. So what would I need to know about this?
Your Z-score to your left and to your right. Opposite side.
How do you mean of the opposite sides?
Like you need to the left of 13 and the right to 15.
But anything that I look up on the chart is always going to be to the left. So the first thing that you said was correct. We need to know Z-scores. So find out what the Z-score for 15 and 13 would be first. Always start off with the Z-scores.
Yes, like 0.3 repeating.
So I need 2 decimal places, would be 0.33.
33.
Okay?
15 was just 1.
So now if I look up the area of the Z-score of 15, what do I get? Or sorry, the area of the Z-score of 1, not 15.
Yeah, 0.8413.
And that represents the area to the left of, oh sorry, that was 15. To the left.
Could you just subtract the Z-score of 13?
Yes. So the Z-score for 0.33 is equal to what?
6293.
And that's everything from this point to the left. So when I subtract them, what's left over is that shaded area. So when I subtract them, what do I get?
0.212.
So to the nearest hundredth, it would be 0.21. So these are examples of calculating Z-scores and then using the Z-score table to find out probabilities. The next example looks at giving you the probability. From extensive testing, an appliance distribution company knows that the average lifespan of toasty toasters is 4.2 years. Standard deviation is 0.65 years, and the data is normally distributed. Now, the company wants to come up with a warranty by which they will not replace more than 8% of the toasters they sell. What warranty should the company offer? So on my Z-score table, what goes in the middle? The middle is my average. So what's my average? 4.2 years. Now, the next part, the standard deviation, that's okay. Data is normally distributed, and the company does not want to replace more than 8% of its toasters. That 8% becomes my area. So an 8% area, I know that each half is 50%. So 8% is going to be pretty much down here somewhere. And that's my shaded area, is my 8%, which as a decimal is 0 decimal what?
8.
0.8. So what I want to do is use this area to find out what's the Z-score. So that if I read the Z-score to the left of it, I get 0.08. So this time when we look on our Z-score table, we're looking in here. And we're looking for 0.08. So where do you find 0.08?
In the one.
In the ones? One where exactly?
Negatives.
In the negatives? Right here? So
Yeah.
0.08 is not an exact value in my table. It's between these two values. But I can't figure out how much in between, so it's either going to be negative 1.41 or negative 1.40. Which of these two numbers is the closest to 0.08?
One on the left.
The point,
0.7.
this one's the closer one, so my Z-score is negative 1.41. That's my Z-score. So now that I have my Z-score, I can find out my value of X. I use that formula. Z equals X minus mu divided by sigma. My Z-score is my 1.41. My X is what I'm trying to find out. And my standard deviation was 0.65. So how do I solve for X?
Negative 1.41 times by 0.65.
Okay, so when I multiply these two together, what do I get?
Get negative 0.9165.
6.5 or 6.4? Okay. How do I get X by itself now?
You gotta minus, or no, add 4.2.
So add 4.2 to each side. So this one we multiplied by 0.65. So when I add 4.2 to each side, what do I get?
3.2835.
And this is years. So what kind of a warranty should I have?
Years.
A manufacturer is not going to quibble over months. They're going to round things to the nearest year. And I can't round this up to 4 years because if I go up to 4 years, I'm going to replace more than 8% of the toaster. It doesn't say that it has to be exactly 8. It says I don't want to replace any more than 8%. So at 3 years, I would be less than 8% replacement. That's what warranties do. So when you're asked to buy an extended warranty, numbers have been crunched to see what the chances are something's going to fail during that extended warranty time. And the amount that people pay into it will more than cover the replacements that they have to do. So it's not that I'm discouraging you to get extended warranty. Just think very carefully about the item that you're getting extended warranty for and whether or not it's worth that extended warranty. Okay? So if it's extended warranty on an iPhone and you're hard on phones, it might be worth it. If it's an extended warranty on a laptop that you don't necessarily use all that often, that stays stationary, you might not necessarily think it's worthwhile getting the extended warranty. Okay. It was found that 62.3% of the shrimp harvested at Shrimp Harvest Farms had a mass of more than 135 grams. If the data is normally distributed and the mean mass of the shrimp was 146 grams, determine the standard deviation to the nearest 10. What goes in the center?
146.
Okay, where's 135 going to go?
Just to the left.
What else do I know?
62.3%, which would be like here. To the left.
To the left or to the right?
Right.
To the right. If I look at this, it has to be to the right because it's more than 50%. So this area in here has to be 62.3%, which as a decimal would be
0.62.
So then, if I go to my Z-score chart, because what I need in order to use this formula, because this is the formula I would use to find standard deviation. I have X, that's my 135. I have mu, that's my 146. I need the standard deviation, but I also need a Z-score. And I can use the probability or the percentage to find my Z-score. Now when I go to my chart, am I looking up 0.623? Why not?
Because it won't be the exact number.
There's another reason though.
That's to the right.
It's to the right. And what does my Z-score table give me? To the left. So I need to figure out what is the area to the left. How do I figure that out?
Your Z-score 35. Go 135 minus 1.
But when I try to do that, I can't divide by standard deviation because I don't have it. What do I know about the whole curve? What does it add up to? 100%. What percentage do I already have taken up?
62.
So what would be left would be this part to the left. So I would take my 0.625 and subtract it, or 623, and subtract it from 1.
Of course.
0.377.
That's the area I'm going to look up inside the Z-score table. So 0.377.
It's like negative 0.3 around 0.03 and 0.02.
So 0.377. Right there. Because it's definitely closer than the 0.3745. So this is negative 0.31. So my Z-score would be negative 0.31. Now that I have a Z-score, I can plug into my formula. So to solve for sigma, I'm going to multiply each side by that symbol first. What's 135 minus 146? And then to get sigma by itself, I'll divide by the negative 0.31. What do I get?
35.48387.
So to the nearest 10?
35.5.
So the standard deviation of the shrimp would be 35.5 grams. Okay, last question. The marks of a large number of students have been represented on a standard normal distribution curve. The values given represent the number of students in each area. So From here to the right is 1,250 students. From here to the left, all the way to the end, would be how many students?
1,250.
So how many students in total? How much? 1,250 on the right-hand side.
Right.
Means there has to be 1,250 on the left-hand side, so there have to be 2,500. So if I want to determine the value of this Z-score, what I want to do is I want to find out how many students are left over in here,
You go 1,250 minus 42.
okay? And what would that give me?
798.
So that's the number of students in this area. Now I need to figure out what would be the probability or the value of that area. So how would I find out that percentage or that amount? Well, it's 798 students out of,
Or 2,500.
so what's 798 out of 2,500 students?
0.638.
0. Point what?
6384.
It doesn't make sense.
0.319.
Thank you.
I typed in the wrong number.
How did I know yours didn't make sense?
Because I used 1,250.
But your number was 0.63.
84.
How did I know that that couldn't be right?
Because that's more than half.
It's more than half. And if I look at my diagram, this number here can't be, this area can't be more than 50%. So from there, I can then conclude that this number had to have been wrong. So now that I have this area, that's what this is in here, I can go on to my Z-score chart and find out what the Z-score is that matches up to that area.
Negative 0.4, 0.07.
So negative.
0.07.
Good. Okay, so your questions that I would like you to work on. Oh, sorry, 2, 4, 6, 7, 8, 10, 11, and 12.